Alright, time for the math. Easy solution to discuss. Logarithmic differentiation is an amazing way to basically simplify complex equations to do derivatives of them easily. Basically, we just combine logs and implicit differentiation to simplify derivatives. So basically, if let's say we have an example, complex equation. Let's say y is equal to x34 times x squared plus 1. All divided by 3x plus 2, 5. So here we could use the quotient rule and then combined with product and chain rule. But this is actually, this is really complicated. But when we don't want to do that, it's just going to take forever and then the calculation is going to look ridiculous. But what we could do is basically ln both sides to make it simplify it. So what I mean by this is if you take the ln of both, or log, or ln is better, natural log. So basically we're gonna get ln y. We could do this because these are equal. The equation just means these are both are equal. So if we're lnning, we're just not changing anything. So now we're gonna have ln x34. The reason we're lnning, I'll show you in a bit, is because we can take advantage of the log rules that I showed in my other video on logs and ln. Basically, you could simplify these equations. And I showed my other video. I'll just do a little quick sidetrack. We'll have if you have ln a times b, this just equals to ln a plus ln b. And if you have ln, let's say ln. So if you have ln a divided by b, you're gonna have ln a minus ln b. So I proved this in my other video. So basically, we're just gonna simplify this whole thing. So this is gonna be equal to, we'll just write it here, ln y is equal to, so basically ln this one plus this. So we could do this all in one step. So we're gonna have ln x34 minus ln, this is plus ln, this is square root x squared plus 1 minus ln, this one is 3x, that's divided by. And then another rule that basically now we have this, and another log rule we're going to use is basically if you have ln of, let's say, x a, this just equals to ln, no, this just equals to a ln x. See my other video on the proofs of all these? So we just look at this one. So we're going to have ln y equals to 3 over 4 ln x. This is power of 1 over 2. We're going to have 1 over 2 ln x squared plus 1 minus ln 3x plus 2 power 5. And now here we could just do derivative easily. So we're just take the derivative of basically the derivative of ln y is just going to be 1 over y. Then using we're going to do implicit differentiation here. Then using chain rules, it's going to be y prime. Remember, y prime in this case is dy over dx like usual. So derivative in terms of x, change in y over change in x. Then this is going to be equal to, well, derivative of ln x, 1 over x, so 3 over 4 x. This one's going to be plus, basically 1 over 2 x squared plus 1. It's 1 over this. And then this one is the chain rule. This is 2x times by 2x. All minus by, this one's going to be, well, this one I forgot to put the 5 here. So just put the 5 here and erase that. So we're going to have, so this will be 5 over 3x plus 2, then times by 3 as derivative of inside using chain rule. So to simplify this one, we're going to have y primes equal to y times 3 over 4 x plus this one, this cancels, so we'll have basically x over x squared plus 1 minus 15 3x plus 2, and we know what y is. That's just the top. So y is basically this thing right here. Okay, so I just pasted it here. So we're gonna have y prime is equal to, well, this one is just y, and then times by this bracket in here, so 3 over 4x plus x over x squared plus 1 minus 15 3x plus 2. Okay, so we got that. That's our answer, and this saved us a lot of time instead of doing the other way, which would have taken forever and it would have just looked ridiculous, like the equations doing quotient and product rule. So, but no, the problem here is, the problem here, if you were to graph, let's say y is equal to ln x, then the graph is actually something like this. It looks like this. So this is, let's say y, this is x, and basically it's not defined for, so it's only defined for x is greater than 0. So, but then we're doing the ln of both sides, right? So if we have f of x, say y is equal to f of x, and let's say if for this case where f of x is basically less than 0 for some x, then basically we can't do ln of, then this is ln f of x, we take ln both sides. This is not defined, so we can't just do that. But the good thing with ln here, if we have, let's say if we want to go find out what y of ln absolute value is, so we could actually do the absolute value. So if we have y is equal to ln absolute value of x, to get the derivative, basically we just have to separate this into two functions. So we'll have y is equal to, well, basically for, it's equal to ln x for, so x is greater than 0, and it's equal to ln negative x for x is less than 0. So basically, what this means is for, if it's less than -2, -2 times negative is positive, so it's always going to be absolute value. So that's what this equation is. And then if we take the derivative, y prime is going to be equal to, well, you got to do both of them. It's going to equal to 1 over x for this, for x is greater than 0. And this one is going to be 1 over negative x, and then using chain rule, -1. So this is equal to 1 over x as well, for x is less than 0. So basically we know that y prime is equal to, well, 1 over x. It's regardless. Where y is equal to ln absolute value of x. And this is also equal to basically just ln of x, even if x is not absolute. So we're going to get the derivative is the same thing. So now that getting back to this one, if it's not defined, we can still do absolute values. So all we do is take the absolute value of fx, and then we could just do ln absolute value of x, absolute value of y, and ln absolute value of x. And then we could just go on as we would do regularly. So then we couldn't do it for every value, but then for absolute values, at least we could get the derivative using natural logs there. Yeah, well, that's all for today. Hopefully you learned this amazing method of solving derivatives of complex equations. And just remember, if fx is not defined, and if it's less than 0, then you can't do ln, but you could at least get the absolute value of it. Well, that's all for today. Hopefully you learned, and stay tuned for another math easy solution.